Hey sports fans, welcome to Planet Numeracy. It's Mark Nolde again. Today we're going to be talking about logarithmic functions, so stay tuned. Okay, so in this lesson we're going to be studying logarithmic functions. In this section, it's important to know that a logarithmic function is nothing more than the inverse of an exponential function. So if you remember, exponential functions originally looked like this. So every exponential function, I was on erase, every exponential function is kind of going to look like this, right? And as such, this will always pass the horizontal line test. And if you think back to a couple chapters back, the horizontal line test told us that there was going to be an inverse to a function. In other words, two functions that undo each other. So let's look at the exponential function. So exponential function, y equals the log base a of a number x. So y equals log base a of a number x. So the reason why we're sort of switching the x's and y's around here is for when we graph these guys, it's going to kind of look like this. So this function here will always have a graph, not always, but it'll have a graph that looks like this. All right. So in a manner of speaking, it's an inverse. Here's my y equals x line. It's an inverse of this guy right here. Well, that's not perfect, but you get the idea. This is the logarithmic function in green. Switch back to green here. This is the log function. And the yellow is the exponential function. So these two things are going to undo each other. So a lot of times students think of logarithmic functions and they think, ugh, logs, that sounds hard. But a log is nothing more than an exponent. It's the exponent that you're looking for. So we'll start with the common log. Okay, log base 10. You do not have to write a 10 down, but it's understood. It's implied if you just write log. The same with a natural log. Well, that's a bad example. Let me erase that. It's the same as if I wrote an x plus 2 equals 5, like an equation. We know there's a 1 in front of this x, but it doesn't have to be written. It can be written. It's not wrong to write it that way. Same way that a1 as an exponent is understood. Every one of these terms has an exponent of 1, but we don't write it because it's understood. So that's kind of the thing with this right here. This is called the common log. So that's the one we usually start with. So let's go to the next screen and we'll look at a couple of common logs. All right. So if I take the common log base 10 of, we'll do one that we know the answer to, 100. So that means, well, I'll put the 10 in. So what we want to know is 100 is equal to 10 to which exponent? So we know that 10 squared is equal to 100. Therefore, this is equal to 100. Or I'm sorry, this is equal to 2. So 10 squared equals 100. So another way to write this is a logarithmic equation. If I wanted to, I could rewrite it and say 10 squared equals 100. This is an exponential equation. So exponential, I'll abbreviate it, and logarithmic. Logarithmic. Okay. All right, so let's look at a couple other ones here. Let's say I have log base 10 of 1, log base 10 of 2, log base 10 of 3. Actually, let me undo. I don't want those. Those are what I want my answers to be. So I'm going to change this to a 10 and a 100. So we already know that this is a 2 because 10 squared equals 100. So let's go back up here and look at log base 10 of 10. So 10 to what number equals 10? Well, that number would be 1 because 10 to the 1 equals 10. And then finally, 10 to what number equals 1? Well, we know that any number to the 0 equals 1. So thinking of it this way, 10 to the 0 equals 1 gives us an answer. So naturally, the next one would be log base 10, or common log of the next multiple of 10, 1,000. So we have 3 zeros there. In other words, we know that 10 cubed equals 1,000. All right, so here's where it can get a little bit tricky until you understand these logarithms, is what happens if, let me scooch over a little, what happens if I put something in here and say, what is the log of 500? Right, what is the base 10 log of 500? Well, let's see. We know that 10 to the 2 power, scooch back over, 10 to the 2 power is 100. So 10 to the 2 power is 100. Also, 10 to the 3rd power is 1,000. So 500, you scooch over here, 500 is between 100 and 1,000. So the log base 10 of 500 is going to be between 2 and 3. So it's going to be 2 point something. I don't know right offhand because I don't have my graphing calculator. But 2 point something. It's going to be a number between 2 and 3. Let me look that up real quick for you. So the log of 500 is about 2.699. I ran and grabbed my calculator. So notice this number, 2.699, is between 2 and 3 because 500 is a number between 100 and 1,000. So the exponent used with a 10 is between 2 and 3, or 2.699. It goes on a little bit longer than that. But that is the idea with these logarithmic functions, or using logarithms. Remember, a log is an exponent.